What's going on, guys? Tom here, and in today's video I'm going to be teaching you the basics of GDScript within Godot 3.2. So let's get started. Okay, so before we start writing any code, I'd just like to give you an introduction to GDScript itself and give you a brief explanation of what it is and how it can be used to make games within the Godot engine itself. So I'll bring up the documentation, and this is the Godot Engine 3.2 documentation that's available directly on the website. And you'll see here that we have GDScript basics, and here it explains GDScript. It says GDScript is a high-level, dynamically typed programming language used to create content. It uses a syntax similar to Python, meaning blocks are indent-based and many keywords are similar. Its goal is to be optimized for and tightly integrated with the Godot engine, allowing great flexibility for content creation and integration. So, what we're saying here is that GDScript is a programming language, a dynamically typed programming language, which we'll get to a little bit later on in this video. And it's very similar to an existing programming language out there called Python, which is hugely popular, and there's masses of resources out there on Python that will still be applicable to the GDScript programming language itself, which is fantastic because that means not only do you have all of the documentation here for GDScript, but a lot of the documentation that's out there for Python is still completely relevant, and learning Python will be a massive bonus if you plan on using GDScript in the long term. Okay, so the next thing for us to do is to open up Godot, and I'll start teaching you the basics of GDScript. So we have Godot open here, it's version 3.2, and I've just created a very simple 2D scene with a world node and a player sprite in the middle of the screen there. To create a script in Godot, there's a couple of ways. The first thing we can do is we can simply right-click in our file system and click on New Script. This will open the Create Script dialog, and here you'll see that we have a choice of language. We can choose Native Script, GDScript, or Visual Script. For this tutorial, we're going to keep it on GDScript. And we have an inherits option. You can leave that a node for now, and we'll cover that in a later video. And we have a template option. Again, we'll leave that for now, and then a path for where you want to store the script. Now here, I'd advise that you change the default name it's given it from new script, and we're just going to call it player.gd. And then click on the create button. What that's going to do is it's going to create a player.gd file in the bottom left corner, and you can double click on that to be presented with Godot's IDE. Now I'm just going to bump up the font size here a little bit before we get started in learning some of the GDScript basics, so that you can see it a little bit better in YouTube. So first of all, we're going to delete all of this, and I'm going to gloss over this extends node for now. It's a little bit of an advanced concept, and it's not something that's hugely relevant for this tutorial, but it will be when we get later on in these videos. So I mentioned before that GDScript is a programming language. Now, what that means, if you're not familiar with programming languages, is that we can tell the computer what to do by assigning things called variables and running things called functions. Now, a variable is simply a piece of data that we want to store within the application. Now, this could be a number, it could be a piece of text, it could be a true or false value, it could be any number of things. And in order for us to declare a variable, in GDScript we simply type the keyword var, V-A-R, and you'll see there that that's highlighted in red. Now we give it a name, so for this example I'm just going to call it number. And then we assign a value to that variable. And to do that, we type equals, and then we give it the value we want. So here I'm just going to assign the value 5. And there we've simply declared a variable, a piece of data that we want to store something in. We've given it a name, number, and we've assigned it the value 5. Now we could do the same for a piece of text. We can say var message equals, and then to assign a piece of text, we have to wrap it in quotation marks, and we can say hello world, which is something you might see if you're new to programming. You'll see this all over. Every single application starts with hello world. Now I mentioned before that you might want to store a true or false value. Now you can do that by saying var, and let's give it a name like alive, equals true. Now, if you wanted to say that the player wasn't alive, you could simply change that to false. Okay, so that is the basics of variables, and variables come in really handy when we want to pass data around our application, or in this case our game, and we want to modify values. So for example, think of a score that you might want to increase every time the player does something, or you might want a variable to, like the one we've just declared, say whether or not the player is alive or dead. Or perhaps you just want a piece of text, also known as a string in programming languages, to display a message to the player whenever they achieve something. For example, a little pop-up on the screen that says you've collected a coin or something like that. Now, variables are great, but on their own they don't really do anything. And in order for us to use these variables, we have to use them in what's called a function. A function is a chunk of code that runs and will do some sort of action. It might produce a value, it might add two variables together, it might call another function which then does something else. In GDScript, every single script has a function called _ready, which will run as soon as this script gets loaded into your game. Now, to define a function, we simply say func, and then we give it a name. So in this instance, I'm going to define that ready function so that we can start seeing some of this script come to life. We're going to say _ready. And you'll see here that it's given us some form of auto-completion here, which is really, really helpful as we start to get more familiar with this and you want to start bashing out scripts really, really quickly. The auto-completion is fantastic for that. You'll see that it's requesting some brackets here. And we open and close these brackets and we end the function definition with a colon. That tells GDScript that we're ready to declare the chunk of code that is going to get called whenever this function runs. We're going to press enter here and you'll see that it's indented slightly. It knows now that we're inside a function and it's indented that to identify that it's within this function itself. Now, you'll remember from the first part of the video where I opened up the documentation that this language is based on Python, which means that white space, i.e. spaces and tabs, are extremely important in this language. They get interpreted by the engine as we are inside this function now. If I was to say func something else here, then because it's not indented inside of this function ready, we know that it's outside the scope of the ready function and it's a completely different thing. Again, if I was to say var something equals 5 here, where it's not indented, then it becomes a global thing, just like these ones here. However, if I was to indent this something variable now becomes part of the function and can't be accessed by things outside of it. Okay, if I press enter now, you're going to see that it's indented automatically, and that means that we are inside this function's definition and we're ready to start writing code that runs exclusively inside this function. Before we start writing any code, I'm going to introduce you to a fundamental concept within programming, within any programming language, and that is comments. Now, comments are really useful if you want to sort of keep track of what you're trying to do in the code, or if a piece of code is particularly complex, you might want to use comments to explain what it is you're doing. You might wonder why you're doing that if you're the one writing the code and you think you understand what's going on, but believe me, comments are invaluable. 6 months down the line, when you come back to a script and you think, what was I writing here? What was I trying to do? Comments can be really useful there. To write a comment, we simply enter a hash, and now we are writing a comment. So here I'm going to say print the string, and remember string means a text, a piece of text. So print the string hello world to the output window. And you'll see the output window is actually down the bottom here. So what we want is we want to print the string hello world, which is luckily for us stored inside this message variable. We want to print that out to this output window here. To do that, we're going to call another function. Now, Godot has a ton of functions declared that you have access to within any of your scripts. We won't cover them all today because there are literally hundreds of them. However, there are some that are really, really useful, and one of these is the print function. So we simply type the word print. You'll see it's gone red there. It's identified that it's actually a function. We're going to open our brackets, and now we need to give it a string. So we could simply put some quotation marks here and say hello world, and save that. Now, before we do anything else, we need to make sure that this script runs whenever we run our game. So to do that, we're going to right click on our player and we're going to press attach script, and we're going to select the path to the player.GDScript and press load. And now you'll see that this has a little script icon here that indicates that a script has been loaded to this, and it's this script here. So we're going to save that, and we're just going to press play here. It's going to tell us that there's no scene being defined to run, which is fine because I haven't set that up yet. We're going to choose our world scene and press open. And now if we run this, down at the bottom left here, it's a little bit small, but you can see that it says hello world. So that's great. So we know now that this script is being called from our game. The ready function has been called because the game has noticed that there's a script attached to the player. It's identified the ready function inside it. It's been called by the game, and it's seen the print call here, and it has printed out the words hello world to the screen. Now, you'll notice again, earlier we defined a variable called message, which contained the piece of text hello world, the string hello world. So we could simply replace this whole piece here with our variable name, so message. So now instead of having the string literally defined here itself, we are now referencing a variable that we declared at the top of the script. Again, if we save that and press play, you'll notice that it still says hello world at the bottom. And if I change this to hello world from Tom, save this and press play, you'll see that hello world from Tom has appeared at the bottom left. Okay, so that gives you a very brief introduction on how to call an inbuilt function, but how do we define our own functions? Well, it's quite simple. We can come down to a new line, make sure that we're not indented anymore. We don't want to be inside that ready function. And we're going to define our own function here. So we're going to say func, and we're going to give it a name. Now, we don't need to put underscore in front of this. That's a bit of a naming convention for private functions, and I'll get into that in another video. It's a topic for another time. However, if you're writing a function, you don't need to put that underscore in place. So I'm just going to leave that out, and I'm going to call this function the add function. I'm going to open some brackets up, and now here's where we can start doing something powerful. Now, functions can take what's called parameters, and parameters are things that that function will be able to access and then act upon inside the function itself. So for example here, I'm going to say A and B. We're going to take two parameters. We don't know what they are right now. However, inside of this function definition, you'll see what we're going to do with those two parameters. So we're going to put our colon on the end. Always has to be a colon. We press enter and you'll see again it's indented. Now I'm going to introduce you to what's called operators. Operators are symbols that you can use to perform a particular action to a variable. And it's just like maths really. So for example, we could declare a new variable here, var result equals, and then what we're going to do is we're going to say A plus B. Okay? And then we're going to simply call our print function again. We're going to say print, and we're going to print the result out to the screen. Now we need to be able to call this function. So instead of printing our message here, I'm just going to comment this out. And if we comment out a piece of code, that no longer runs. And I'm going to say add, and we're going to give it our original number. So the number we declared at the top, which is number, this one here, number equals 5. And then we're going to give it another one. We're going to say 10. So we want to add our number 5 to the number 10, and then it will print that out to the screen. So let's press play. And you'll see here at the bottom, we now have 15. So we can define another function, func subtract. And I think you're starting to get the picture now. So we have A and B, and we can say var result equals A minus B. We're going to print that result out to the screen as well. And we're going to call it here, subtract. And you'll see that the auto-completion is actually noticing the way our function has been written, and it's giving us some auto-completion there. It's saying that we want an A variable and a B variable. So we're going to say 10 and 5. We'll run that, and we expect it to say 15 and then 5 because it's calling both of those functions, the add and the subtract, in sequence. So we've got 15 and 5. Okay, so let's delete these because we don't need both of those on the screen. Let's keep it clean. We're going to define another function, and this time I'm just going to call it operator, and we're going to say A and B. Now we're just going to use this to play around with the available operators that we have. So let's call operator. Let's give it the number 10 and the number 3. And we're going to play with a different operator. This time we're going to play with the multiplication operator. So we're going to say var result equals A multiplied, which is the asterisk sign, B. Again, let's print this out to the screen. So we expect the result to be 30. And it is. We see 30 down at the bottom here. Let's try changing the asterisk to a / and see what that does. Let's press play. We get the result 3. Now the reason we get the result 3 is that this is the division operator, and you'll notice that 10 divided by 3 isn't exactly 3, but we're working with whole numbers here, so it's actually rounded it down to 3. And we have one final operator here that I'd like to show you, and that is the remainder operator, which is the percent sign. It's sometimes called the modulo operator or the mod operator, but effectively what it does is it divides the two numbers and gives you the remainder. So we're looking for 1 to be displayed on the screen here, and indeed we get 1 because 3 goes into 10 3 times and there's 1 left over. Okay, so that gives you an introduction to operators and how they can function on a variable, particularly a number variable in this instance. And let's just see how an operator might function on a piece of text, so on a string. In this example, if we change the result to be I am, and then plus, and then B. So let's take away the A parameter, and let's call this operator here, and let's just say 30. We press play, and we get an error. Now the reason we can't add these two variables together is that this here is a different type of variable than B. So this is a string type, and this is a number type or an integer type. Now we can do something called string interpolation here. And what we could do is we could say %d, which says I am, and then we're basically creating a placeholder for a decimal number. And we're going to say here %. Now this is the remainder operator. However, when we're using it on a string, what it actually does is it interpolates whatever variable comes next into the string. So if we say %b here, and then we refresh this, we're going to get I am 30. So you'll see that operators behave differently depending on what context they're used in. So for numbers, the plus and minus and division all work on mathematical operations. However, when you're using it on a string, for example, the modulo operator or the remainder operator becomes a string interpolation operator, which means that it will take variables that come after it and place them into the string wherever the placeholders have been put. Now that's a little bit more of an advanced topic, so I won't go any further into that right now, but I just wanted to show you that operators can indeed function in different ways depending on the context where they're used. Okay, so we've covered operators. What I'd like to show you next is conditional statements. So let's define another function here, func, and we're going to call this conditional. And we're just going to give this a parameter here called a, or let's actually call it age. We're going to put our colon on the end and press enter. And now what we're going to do is we're going to write a piece of code. Let's document this as we go. Let's put a comment. We're going to say if age is greater than 30, then print you are awesome. Otherwise, then print you are cool. I don't know why I chose those two words, but there we go. Okay, so we're going to say if age is greater than 30, then we're going to print you are awesome. Otherwise, we're going to print you are cool. And to do this, we're going to use a conditional statement, and a keyword. The keyword for that is if, which is exactly how we've put it in the comment there. We're going to say if age. Now we're going to say greater than 30, so we're going to put a right angular bracket there, And again, this is just like it would be in mathematics. We're going to say if age is greater than 30. We're going to put a colon at the end here because we're defining a code block, just like a function. We're defining another block, and you'll see it's indented just like the function there. So inside this, we now know that age is greater than 30, and we're going to print you are awesome. Okay, so how do we say, well, if that's not the case? Well, to do that, we simply write else and put another colon. So we're saying if age is greater than 30, we're printing you are awesome. Else, or otherwise, we're going to press enter. It's indenting again. We're inside another code block. So in this case, you're not greater than 30. We're going to say you are cool. Okay, so let's remove this operator function here. Actually, let's just comment it out by putting a little hash in front of it. And we're going to say conditional. And we're going to pass in an age. We're going to say 31. So we're expecting it to say you are awesome. We're going to press play. You'll see down below it says you are awesome. We're going to change this now to be 20. We're going to press play and it says you are cool. Okay, so we have that age is greater than 30. We're going to do something. Otherwise, we're going to do something else. But what if we had multiple conditions we wanted to check? What if we wanted to say, well, if you're over 30, then you're awesome. But if you're under 12, then you're cool. Otherwise, then you are, and it's just going to print their number. Let's just say that. So we're going to say, if age is greater than 30, you are awesome. We want to put another condition now. We don't just want this to be everything else is you are cool. We're going to say if. And this is going to allow us to define another condition here. So we're going to say if age is less than 12, I think we said. Then we're going to say you are cool. So let's put that there. We've just got rid of the else statement. And then for everything else, so else print, we're going to say you are, and then we're going to do that %d again, and %age. So we're just using that string interpolation again, %d, %age. So let's try that again. We're going to run. It's going to say you are 20 because we're not greater than 30 and we're not under 12. Let's change it to 11. Okay, now it says you are cool. And if we change it to 33, we get you are awesome. Great, so that is the very basics of conditionals. Now we could go a step further. Let's add a new function here just between the two. We're going to say func. We're going to call it more conditionals. And we're going to say here alive and health. Let's give it two parameters called alive and health. And what we're going to say here is if alive and, so we can use the keyword and to check something else. So if alive and health equals 0. Now you'll see here that I put a double equals. Now the reason for this is that a single equals would be an assignment. We would be trying to assign the value 0 to health, but we can't do that in an if statement, or we don't want to do that in an if statement. So to do an actual equality comparison, we use the operator double equals. So we're going to say if alive and health equals 0, then we're going to print out you died. So let's call that here. Let's comment out that line and say more conditionals. And we're going to say we are alive and our health is 0. We're going to press play and it says you died. Let's do a else print you are alive. And then let's change this here to 10 and press play. You'll see that we get you are alive. However, I could change this alive here to false. And if I press play, we're still going to get you are alive. Now that's because we need to add another condition here. What we could do is we could simply say right at the top, if not alive, then we can print you died again. And what we can do then is we could return from the function. And what that'll do is it means that once we see this return keyword here, it's not going to run anything else after that. It's basically going to call the print function with you died, and it's going to do nothing else. It's going to stop at that point. So if we press play, it's going to say you died. Now this isn't the cleanest way to do this. We could actually modify this statement here to include this condition as well. So we could say if not alive, or, and let's wrap these in brackets because we're doing two conditional checks here. So we're going to say if we're not alive, or we are alive and our health is now 0, then we're going to print you died. So again, we have you died there. Now that's just a way of combining multiple conditions into one single if statement. Now one thing you'll notice here is that I've been calling these functions very simple names like operator and more conditionals and conditional, but actually that's a really, really bad thing to do because it doesn't explain what the function is actually doing. So let's change this one here. And actually what we're going to do is we're going to just change this back to the way it was. So we're going to say A and B, and we're going to make the result A plus B. And we're going to give it a name that makes sense. So in this example, I'm going to say func add. And now that makes sense. This is what I was talking about with self-documenting code. Our function is called add, so we can see that whenever we call that function, for example, add 10, 2, you know exactly what that's going to do. That is going to take those two values and add them together. Same with this more conditionals. What it's actually doing is checking whether or not you are alive. So we can call this check if alive. And again, this conditional one here, it's basically printing out something based on how old you are. So let's call it something like age check. Okay, so for all of these functions so far, let me just comment that one out. For all of these functions so far, all they've done is printed something out to the screen. Now it would be great if we could call add 10 plus 2 and actually get the result of that back out of the function. Now you'll notice before that we called a return keyword, and what that did was returned out of the function and stopped the execution of any further code along the line. We can use that return keyword to actually return a value from a function. For example, no longer am I going to print the result out from this add function here. Instead, I'm actually going to return the result. And then up here we can say var result equals whatever the return value is from this function call. And then after that we can say print result. And now if we run that, we should get the answer 12 popping up in our output window, which we do. So you can use this return statement to return anything from strings to numbers to full objects with nested values. And that's where the power of functions comes in. You can modify values, you can tweak values, you can create new values from scratch and use those return values to then pass into other functions. Okay, so now we've looked at variables, how to declare them and how to assign a value to them. We've looked at functions and how to define a function and to return values from inside a function. What I'd like to cover now is the different types of variables that you can have. Now you'll have seen before when we were doing the addition, you notice that we couldn't add a string to an integer, so a piece of text to a number directly. Now the reason for that is that they are different types. So we have a concept of different variable types. Now there are 4 basic variable types within GDScript. Those are bool, which stands for boolean, which means a true or false value. There's int, which stands for integer, which means a number, a numeric value. We have float, which again is like a number, however it can have decimal accuracy, so we could have 1.5, 1.635, and so on. And then we have a string, which is simply a piece of text. Now you'll notice here that we didn't have to declare what variable type any of these things were. And now going back to the original documentation, that is what a dynamic programming language means. So it means that dynamically, it will just figure out what kind of variable you have created based on what value you gave it in the first place. So for example here, this number equals 5, Godot has worked out that that is an integer value or an int value. Likewise for message, it's worked out that it's a string value. And for alive, it's worked out that it's a Boolean value. Now, what if we wanted to explicitly tell Godot what variable type we wanted to use? And why would we want to do this? So, for example, here we have the func add a and b. Now, when we type in add and open our bracket, you can see that it's expecting a to be a var, a variable. We don't know what kind of variable, just any variable, just a dynamic variable. That isn't really useful if, for example, this add function was to only be a mathematical function. We only wanted numbers to be passed into this. Now, we can do that by writing a colon and then declaring what kind of variable we want here. So we can say an int. Again, for this, we can say that b is an int as well. And now if we open our brackets again, you'll see that it says a should be an integer. Now if I pass in a message here, like a string, and we say hello, and then we give it a number afterwards, and then we save that, you'll see that immediately we've got an error message popping up here. It says at add call argument 1 is assigned type string, and it doesn't match the function's argument type, which is integer. Now, you don't have to do this. You don't need to explicitly tell Godot what kind of variable you want inside functions. However, it can be extremely handy because it means that we'll immediately get little pop-ups here or notifications that something in our script is incorrect, and it can stop your game from crashing later down the line because you've had a chance to identify bugs before they actually happen. Now, we can do the same thing for these variables at the top here. We can simply put a colon directly after the name. We're going to say an int. After this one, we're going to say string. Now notice this is a string with a capital S. And after alive, we're going to say bool. So let's save that. And let's just run it again. In fact, let's call the add function to make sure that everything is still working. We're going to save that and we're going to press play. Everything's still working. We've got 12 there. Let's pass in our number. So we've got number and 2. Let's press play. We expect it to say 7. And indeed, we get 7 at the bottom there. So these are the basic types within Godot. We have, again, ints, strings, bools, and floats, which you haven't seen yet. So a float is simply var, let's call it time delay. I don't know, I'm just picking a random name. We're going to assign it a float. And this could be, for example, a decimal. So we could say 1.565, for example. And that is a valid value for a float. So we've seen the 4 basic types of variables here. However, there are advanced types, and you can obviously define your own types, which again is something for a later video. However, I did just want to quickly show you what an advanced type might look like. Now, a lot of the time in games, you'll be dealing with positions, and to do that, you'll be working with things called vectors. Now, I'm not going to get into vectors and what they are in this video. However, I just wanted to quickly show you what it looks like when you're working with more advanced types. So, for example, at the top here, I'm going to say var, let's say var target position. And we're going to give this a vector2 type. And we're going to simply say that it is a vector2 dot 0. Now, don't worry about the assignment here. That's basically just assigning it to a 0 vector2. And again, we can say var target 3D position is vector3. And again, we'll say it's a vector3 dot 0. You don't actually have to put this in. If you leave that off, then it will automatically be defined as a 0 vector. So you can do that if you want. I'm just going to leave that in for now, just to show that you can assign a variable a value straight away. I'm going to save that, and then I'm going to come down into my ready function. And if I type in target underscore position, you'll see now that when we do a dot, we've got a bunch of different functions that we can call, which are attached to these advanced type. For example, we could call the length function, or not length squared, the length function, and that you'll see there returns a float variable type. And that result will be whatever the length of this particular vector is. Again, I'm not going to get into vectors and how they function in this tutorial, but I just wanted to show you that you can have advanced types. Now, we'll take a look at these more advanced types in a later video. However, I did just want to show you that it is possible to have other value types rather than just ints, strings, bools, and floats. There is one final thing that I did want to show you, and that is the null keyword. Now, null is a bit of a special case. So for example, if we say here nothing, var nothing equals null, and let's just comment this out here. And I'm going to print out the value of nothing. Let's press play and let's see what we get. We get null with a capital N-U-L-L. And basically null is a keyword for I don't have a value. It means this variable does not contain anything. Now that's really useful, for example, if you had something like a target and you wanted to assign something to this target whenever, let's say for example, an enemy came into view of a turret. It might say, right, okay, I know what enemy I'm targeting now. I'm going to place that inside a variable. And as soon as you have a target variable assigned, it could then start triggering some fire functions and start firing at the enemy. However, if that enemy goes out of range, you might want to clear that target, and to do that you would assign it null. So you would simply say something like target equals null whenever you're ready to clear that, and then that would then tell the game that you no longer have a target and you can stop doing all of those fire functions. Now that was a very brief introduction to GDScript. I've basically covered variables, functions and parameters, calling methods, writing comments, using operators and conditionals, and gone through the basic types and a couple of the advanced types there for you. We'll cover a lot more of this in the next video. If you enjoyed today's tutorial, please click that subscribe button and hit the little notification bell. I release new content every Monday, so don't miss out. And as always, thanks for watching. I'll see you guys in the next video.